This is Apollo Control Houston. We're picking up conversation with the crew at this point, and we'll switch to that conversation.
Houston, Apollo 14.
Roger, Apollo 14. Good evening.
Good morning, how are you? Or is it afternoon?
I'm fine. How are you up there?
We're just great, thank you. We're up and brushed our teeth and shaved, and we're just looking forward to a fine day.
Roger, Ed. We saw somebody get up and walk in his sleep and work the disky there about an hour ago.
Yeah, that's right.
Just need to get a little practice, Gordon.
He just had a roughened finger.
Okay, we've got a site handover coming up in about a minute and a half.
Roger. We'll wait for that, then I'll go ahead and give you complete the post-sleep checklist.
Okay, Ed.
Houston 14.
Go ahead, Ed.
Dosimeter readings for you.
Okay, we've handed over, and so I'm ready to copy your post-sleep.
Okay. Alan, dosimeter 1.
What, Apollo Control at 26 hours 3 minutes, you heard those conversations with the crew sounding alert and wide awake. The launch vehicle debriefing time will not be changed. However, it appears likely that other events in the flight plan preceding that may very well take place at the leisure of the crew. We're at 26 hours 4 minutes into the flight. We show Apollo 14 at a...
Houston?
Okay, Houston, gonna reach it now.
Roger, I think we rotated between a couple antennas there. But you're loud and clear now.
For my sleep, I slept for about 4 hours straight, and then another 2 or 3 intermittently, and feel very good.
Roger.
Now, about the same for me, and feel like
Al, this is Houston. You're very, very weak. Would you repeat?
Okay, and the sleep cycle about the same for me. Slept soundly for 4 or 5 hours, and then intermittently for another 2, and we feel excellent up here.
Roger, Al. For some reason you're not nearly as readable as Ed is, and it sounds like, well, I guess I can't really say what the problem is there on your mic. I'm getting a lot of interference when you start and stop a transmission. I got no suggestion of what to do to improve it.
Okay, how do you read this?
That's a lot better, Al.
Okay, the mic is a long way away from the mouth. Did you get the sleep report?
I think we got it. 4 to 5 hours good sleep, and then a little bit intermittent after that. Is that about it?
That's correct. General condition is excellent.
Al, you're still breaking up. I really can't give you a good description of what is wrong, but you're just not very readable.
Okay, stand by on that one, Houston. We'll work on it.
Okay.
And Houston, I'll go ahead and start charging Bat A with your concurrence, and we have changed the LiO canister.
Roger, that's affirmative. You can go ahead with that, and also give us the LEM CM Delta P as shown at the 27 hours there when it's convenient.
Okay, stand by.
And Gordon, it's Stu. How you?
You're loud and clear, Stu.
Okay, I guess on my sleep I'll split it with you about half. I'll say I got 5 hours.
Roger.
My mattress was hard.
Roger. when you're ready to copy, I have some words on some changes we figured out for the flight plan.
Stand by a minute. Okay, you can go ahead with your change to the flight plan.
Okay, before we start, one reminder is that when you went to sleep, we didn't get any pre-sleep checklist. If there was anything out of the ordinary there, we'll please pre-sleep report that was, and we'll take any standby. I'm getting some words from the surgeon here. Okay, just disregard it. Just try to. We'll need the both the pre and post sleep reports from here on out. Okay, on the flight plan, if you're ready.
Okay, go ahead.
Roger. We're going to delay the launch vehicle systems debriefing until 28 hours. And the P-23, which is scheduled at 28:30, we're going to cancel, which will save us some RCS. Along that line, the results of the last P-23 that Stu did, the horizon that he shot at was 28 plus or minus 5 kilometers, and that's right on the pre-flight value, so an update will not be required. And your average error for pointing error was 3 arc minutes, which is right in there with the best ever recorded. And the expert gives you a pat on the back, Stu, and said it was an outstanding job.
Joe, thank you, Gordon.
Okay, on with the flight plan. The Delta V test and null bias check and the P-52, we're going to delay that till 29:10 GET.
Okay, so far I have that we do the launch vehicle debrief at 28 hours to 27 hours. We're delaying the null bias in the P-52 at 28:10 until 29:10. We're canceling the 23 at 28:30.
That's affirmative, Al. And then further after that, we're going to delay the exit of PTC until 29:55. And when we do exit PTC, go right into the Midcourse 2 pad attitude.
Okay, PTC to 49:55 and then set up Midcourse 2.
Roger. And all other activities will be nominal except on the wastewater dump, we want you to dump to 0% quantity.
Okay, dump the wastewater to 0.
Okay, we have one additional question for the launch vehicle systems performance debriefing. We can either give it to you now so you can think about it, or wait until you get around to it to give it to you, your choice.
We will take it now.
Okay, the question is, you announced during the docking attempts that you thought the booster was maneuvering a little bit. They'd like you to expand on the direction of the maneuver, the type of maneuver, lateral or oscillating or any other words to that effect, the approximate time the maneuver was first observed, whether it was before the first docking attempt, between the first or second, or if you can relate it to any other activity. Any observed vents from the launch vehicle during the maneuver? And anything else unusual or unexpected that you noticed? Over.
Okay, question number 10. Describe the type, direction, and time relation of the booster maneuvers during docking and any events that we noticed during the maneuvers.
Roger, and I was just thinking as I read it that on that time we can probably go back on a tape and find out when you mentioned it as far as tying down the time accurately. That might be easier for us to get than you.
Okay, that will probably help us. Thank you.
Hey, that's no sweat, Gordon. I remember the comment when I made it and what the circumstances were.
Okay, Stu. I think that takes care of all the words I got for you right at the moment.
Houston 14.
Go ahead, Ed.
Our left CM Delta P is 0.3, and I'm standing by for a command module consumables update.
Roger, Ed. Copy 0.3. We don't have the figures on that update yet. One thing I didn't mention is that we are planning to do Midcourse 2 as is shown in the flight plan, and that we'll do it such that it will require a clock update as scheduled at about 54 hours and 30 minutes in the timeline.
Okay.
It'll be a roughly 40-minute
Looks
clock.
like we...
Roughly a 40-minute
Say again,
change.
Gordon, how much?
It'll be roughly 40 minutes, and I still haven't got used to which direction it is. Actually, it's like going into daylight saving time. It'll move your clock ahead.
Okay, Gordon. Looks like we get to SIM that TFM update after all.
Raj.
Apollo Control Houston, 26 hours, 15 minutes. The Midcourse Correction 2 is scheduled for a ground elapsed time of 30 hours, 36 minutes, 7 seconds, with a delta V of 71.3 feet per second, performed with the service propulsion system engine, and burn duration of 10 seconds. This will force the trajectory to arrive at the moon on time Greenwich Mean Time, thus requiring the GMT liftoff update. We're at 26 hours, 16 minutes, continuing to monitor, and we show Apollo 14 at 106,915 nautical miles away and traveling at a speed of 4,865 feet per second.
Apollo 14, Houston, over.
Go ahead, Houston.
Ed, I that consumables update now if you're ready to copy.
All right, go ahead.
Roger, GET 2600. RCS total 86. Quad A 85. Quad Bravo 86. Quad Charlie 86. Quad Delta 87. H2 Tank 1 87.98%. H2 Tank 2 85.7%. O2 Tank 1 93.4%. Tank 2 92.6%. Tank 3 54.6%. Over.
Okay, I read back GET of 26 hours. RCS total 86%. Quad A 85, B 86, C 86, D 87. Hydrogen tank 1 87.98, 2 85.7. Oxygen tank 1 93.4, 2 92.6, 3 54.6.
Roger, Ed, your readback is correct, and we have had considerable discussion today about the docking probe. There are still 4 questions as a result of all these discussions that we would like to put to you, the crew. It'll probably take some discussion to answer them. There's no hurries, and don't let us interrupt breakfast there. When you're ready, we'd like you to take these questions and comment on them.
Okay, Gordon, we'll probably be through here in another 45 minutes, and we'll jump right into that one then.
Roger.
This is Apollo Control Houston at 26 hours, 37 minutes now into the flight of Apollo 14. We now show the spacecraft at a distance of 107,892 nautical miles, traveling now at a speed of 4,827 feet per second. In approximately 20 minutes, we will have a shift change here in Mission Control. The maroon shift replacing the orange shift of flight controllers. The orange team, headed by Pete Frank, came on duty at about 19 hours ground elapsed time until the last hour when Mission Control, in fact, received a call from the crew. Mitchell, Rusa, and Commander Al Shepard had spent almost this entire time in a rest period. In the Mission Control Center, a flight plan update was in progress for a better period of the time. The plan, as it evolved, did not call for awakening the crew until 27 hours ground elapsed time, but the crew woke up almost per flight plan schedule. Commander Al Shepard reported 7 hours deep and intermittent sleep, as did Lunar Module pilot Ed Mitchell. Stu Rusa reported some 5 hours sleep time. As we look ahead to the next shift, we also look ahead to the Midcourse 2 maneuver, and as we had reported previously, that's scheduled for a ground elapsed time of 30 hours, 36 minutes, 7 seconds, with a delta V of 71.3 feet per second and burn duration of 10 seconds. This will require a GMT liftoff update, which effectively at some future point in the flight plan will move the GET clock here in Mission Control ahead about 40 minutes. Because of the absence of activity with the crew on this shift, there is no plan for a change of shift news conference. We're at 26 hours, 39 minutes into the flight. We show Apollo 14 at an altitude of 108,012 nautical miles and a velocity of 4,823 feet per second. This is Apollo Control Houston.
Houston, Apollo 14.
14, Houston, go ahead.
Say, Gordon, do you have any choice news items for us today?
Gosh, I think you all have been making all the news. I haven't heard anything very significant, and don't have any good summaries for you right now.
Okay.
Apollo 14, Houston.
Go ahead.
I do have one story here I'll read from the front page of the Houston Post, this morning's edition. The headline is, Mrs. Shepard ate an omelet during docking problem. And the first paragraph is dateline Cape Kennedy, Florida. Mrs. Louise Shepard sat in her motel room eating an omelet while her husband and the two other Apollo 14 astronauts worked with a bulky docking latch that for a time threatened their moon flight.
She was sure calmer than we were.
Right.
That was Ed Mitchell who responded, she was sure calmer than we were. We're at 26 hours, 54 minutes into the flight. Apollo 14 now 108,668 nautical miles away from Earth. Present velocity, 4,798 feet per second.
This is Apollo Control at 27 hours, 7 minutes. We've completed the change of shift handover here in Mission Control. Flight Director Milton Wendler now sitting at the Flight Director's console, replacing Flight Director Pete Frank. Our capsule communicator on this shift will be astronaut Bruce McCandless. At the present time, Flight Director Wendler is going around the room, checking the status with each of his flight controllers and reviewing the overall mission status. Apollo 14 at this time is traveling at a velocity of 4,773 feet per second, and we've continued to watch that velocity drop off. The current spacecraft altitude is 109,301 nautical miles. One of the principal items that this shift will be concerned with is Midcourse Correction 2. A midcourse correction aimed at targeting the arrival point of Apollo 14 at a pre-planned ground elapsed or Greenwich Mean Time at an altitude of about 60 nautical miles above the surface of the moon. The planned time of that maneuver is at a ground elapsed time of 30 hours, 36 minutes, 7 minutes. And the mid-course correction will change the perigee, or the low point of passage around the moon, from 2,100 nautical miles to the targeted 60 nautical mile altitude.
Houston, Apollo 14.
Apollo 14, this is Houston, your friendly maroon team on station. Go ahead.
Well, hello, Bruce. How are you doing today?
Okay, Ed, how about yourselves?
Great, thank you. Bruce, these questions that are being posed on the probe operation, should I copy them, or shall we just let you go ahead and talk about them, and then we'll get back to you?
Well, I think probably the easiest thing to do would be start going through them one at a time, and if you feel like you need more time to discuss it or to recall the exact things you went through, we can just take the time as we go along. There's no big rush on it. It'd probably be easier than you're trying to prepare a formal report or something and voice it down.
Okay.
And we're just finishing up
It'll
the...
be a little while before we're ready to go that way.
Okay, we're just finishing up the change of shift briefing down here, and probably be 5 or 10 minutes at least before we're ready to roll on it too.
Sounds good.
Hey, Bruce, did you get a good night's sleep? You put in a hard day yesterday.
Yeah, I got up about 1:30 or 2 o'clock this afternoon. Felt real good.
Raj.
We're happy to discover there really is a patch after all. We're constantly reminded of it.
That there really is a what after all?
There really is a patch. Right?
Yeah, how about that? That's a beautiful one.
Hey, Bruce, would you pass on to Ray that it was not 100% at the bench check?
That's to Ray that it was not 100% at the bench check. You mean the equipment loaded on board was not completely represented at the bench check?
That's affirmative.
We've got the backup crew.
I don't know why, but
We've got the backup crew commander standing here monitoring the system.
we seem to be finding a few things around that we didn't see at our bench check, and a few crew preference decals.
Yeah, how was breakfast, by the way?
It was great. Ate every scrap.
Hey, it sure was.
Yeah, and I found my headset all right this morning, too, but there was a little difference from last night.
Okay, you keep us posted on that headset.
Houston, 14.
Apollo 14, this is Houston. Go ahead, over.
We're standing by for the booster launch phase discussion and the probe discussion anytime you're ready to go.
Roger.
This is Apollo Control at 27 hours, 44 minutes. You heard Al Shepard ask the Capcom whether or not we're ready to proceed with the continuing analysis of the probe, and we are preparing to proceed with that analysis. Last evening on this shift, a series of 12 questions were forwarded to the crew after removing the probe in a preliminary analysis. We'll be picking up where those 12 questions left off with a series of additional questions and with additional Apollo program and NASA management officials here in the control center to participate in the evaluation.
Go ahead, 14.
Hey, Bruce, how far away is S-4B from us?
Stand by. I'll see if I can get you a figure on that.
Yeah, and on the same subject, have you got any, give us a roll angle during PTC and some place to point the optics? Wonder if we could see it.
Okay, I'll see if we can get that.
Among the interested officials here in the control center at the present time, who will be participating in this probe evaluation are Apollo Program Director Rocco Petrone, Donald K. Slayton, Director of Flight Crew Operations at the Manned Spacecraft Center, Sig Schoberg, Director of Flight Operations at MSC, and Apollo 14 Backup Commander Eugene Cernan. Also astronaut Tom Stafford has just walked into the control center and is at the Capcom console at this time. This is Apollo Control at 27 hours, 48 minutes. Apollo 14 now traveling at a velocity of 4,704 feet per second, and we show the spacecraft 111,159 nautical miles from Earth. In addition to those officials here on the floor of the control center, we also have Dr. George Lowe, acting NASA administrator, in the viewing room, and Charles Matthews, Deputy Associate Administrator for Manned Spaceflight, alongside Dr. Lowe in the viewing room. We have a series of 4 planned questions which will be asked the crew, in addition to follow-up questions I'm sure that their responses will elicit.
Dean, this is Houston.
Go ahead.
All right, Roger, we'd like to pick up the discussion on the docking probe situation now, if you're ready.
Okay, stand by, just one here. Okay, Bruce, I guess we're all hooked up and ready to go.
15, this is Houston. Go ahead.
Roger, I think we're all hooked up and ready to go.
All right, Roger. I guess number one question would be, was there ever more than one bottle selected on the docking probe, and if so, which ones?
That's negative. We used the primary one, and that's the only one we used.
All right, Roger. Very good. How many times was the extend release position of the docking probe extension retraction switch operated, and for when and about how long was it held in these positions? Over.
Well, it was operated per flight plan for the initial extension, and knockbacks worked normally. We filled the jar, good solid pump, but it would run out. And then it was not operating again until after the problem started. At ground suggestion, we went to extend release, and then back to retract. I think twice, no more than twice.
Okay, so grand total, I guess we could say that you've had 3 cycles to the extend release position, the one nominal one and the 2 after the problem started developing. Is that correct?
Let's call it no more than 4, Bruce. We did one on our own. So 1 normal and no more than 3 additional.
Roger, we copy.
And Bruce, no response at all except for the first one, which went normally.
Okay, and on the first one there, you were actually causing the probe to extend, were you not?
That's affirmative. We extended it, and as Al said, we heard her plunk in, and the talkbacks did their thing, flashed barber pole, and then went to gray as advertised.
Okay, then on the subsequent ones, about all we'd be operating is the capture latch cocking motor.
Okay.
They probably wouldn't feel that in the form of a mechanical shock or anything like that. And
Roger.
you may want to kick this next one around before you answer us on it. Make sure you got all the details lined up. We'd like you to go through the procedure in as much detail as you can on the final docking, including the switch positions, talkback indications, the dynamics, the order of your contact with the LEM drogue, the plus X thrusting, the barber poles, the bottle selection, and the actual probe retraction. I think you mentioned yesterday that you had a 3-second delay in probe retraction, and we'd like to know when that 3-second delay was measured starting, that is, from throwing the switch or from some other event. Over.
Okay, I'll start off by saying that all switches were per checklist. And of course, those are one of the first things we verified when the problem occurred, at your suggestion as well as our own. And so everything was normal up to the point where Stu made his first contact, and I'll let him take it on in from there.
Okay, Bruce, why don't we just back up a little bit, and you asked for the specific one where we got the docking, but let's go back to the first one, and everything looked just real fine coming in on it. I'd say the whole docking operation was just so much like the CMS that it was hard to believe. I mean, the procedures and the view and the response of the vehicle, and I'd say I had 0.2 foot per second closing speed. And then the reaction when I hit the drogue was just exactly like the docking trainer that we had, where you didn't hit the capture latches, but you just went in and banged into the drogue.
Roger, the one over there in building 5.
Well, that's the exact response I got on the first one. I clunked into it, and and then I could tell that I was slipping out, and of course Al didn't call the barber pole, so at that time I did the natural thing and jabbed it with a little plus X. and drove it into the drogue, and we were lined up good on holding plus X, and the alignment, you know, still good on the target, just like you know, you can do in the docking trainer. Okay, and then I realized that it hadn't made contact, so I let her back off. At that time, we called you, and I said, well, I'll try it again and increase the velocity. And on this one, I'm estimating that my contact velocity was about a foot per second. Now, it might have been a little less than that. As you know, a foot per second closing looks like you're going to run right through the thing. So, but I've looked at a lot of these in the simulator, and I'd say that probably the second one was right at a foot per second, and got the same response. And I really can't remember whether that's the one where you told me to try plus X after I hit or not. You know, I had already done that on the first one. But anyway, if this was the one, then I hit, you said hold 3 seconds, I held 4. And no luck at all. We came back out. At that time, I suggested we fall back, regroup, and talk about it. And then y'all pretty much know the story. Then you suggested that we try it again with everything normal. And I guess the second time there was I contacted, and that was not the time I held the plus X. It was the next one on your suggestion. Yeah, the second one, I did it on my own, and then you, on the third one, you said, let's try normal docking and hold 3 seconds. I did that and held 4. And also, it was after the second docking that I noticed the radio scratches, and at that time, that's when I became convinced that from the action and then seeing the scratches that the docking latches were not giving, and were indeed locked instead of the cock position. Okay, so we went through that one as you suggested, and I held plus X 4 seconds, and we're right in the drogue, you know, holding steady, and then we came out, and then down to the last time.
Us too.
I came in, I'd say probably about a tenth, maybe 0.15 in that area, 0.2, maybe a little less. Contacted it, and at contact the attitude stayed fairly good. There was maybe a 1.5 degree, 2 degree pitch up movement on the coas. I then applied the plus X and held it. At that time, that put it in the center of the drogue, and the coas and the reticle and the translation were all just looking real good, and so I gave the cue to Al to retract, and he hit the retract switch at that point, and then I'll let him take it from there.
Stu, before you press on, where in this sequence of dockings did you actuate the extend-release switch position again? Over.
Okay, it would be after the second attempt. It was per your suggestion, the ground suggestion, and we went through the extend-release in through there. No, wait a minute. We tried it ourselves after the second one, didn't we? Okay, consensus here is after the first one, we went back to off and then back to retract. And then after the second one, we went to extend and then back to retract.
Okay, and did you do anything with the extend retract switch after the last unsuccessful docking, but prior to the final successful one?
I don't think we did, Bruce. We told you everything we did with that switch after the first came up, except the one time when I failed it from retract to off, and then back to retract again.
Okay, now, in going through this sequence, did you ever move the docking probe retract, that is the bottle select switch, off of primary 1? That is, did you recycle this switch or do anything in this sequence, or just leave it in that position once you'd initially selected it?
Well, we don't touch that switch until we get capture latches. Stayed in the off position until
Okay.
we use it the way you told us to.
Roger. Copy. Okay, so we're coming up on the final successful docking here, and told us that you got this 1.5, 2 degrees pitch up in the coas, but looked pretty good. You applied plus X and held, and I think that's where I broke in. Go ahead.
Okay, and then on the plus X, then that brought the the coas right down, and the alignment then when everything was fine, and translation was real good all the way, except like I say, for that small pitch up, 1.5 or whatever it was, right at contact as the probe sliding into the drogue.
Okay,
And then when Stu called out retract, I went to retract position on primary 1. And it looked pretty normal from there, just long enough to say to yourself, well, it hasn't worked. And then it went barber pole, then gray, and simultaneous with that, we had the feeling that we'd hard dock. So it's probably about a 3-second time period from the time it went to primary 1 until I had the barber pole, and approximately a second later after that, the 2 gray and the hard dock.
Okay, stand by. Uh, 14, Houston.
Go ahead.
Roger, were you thrusting plus X all the time from initial contact until the time that you got the hard docking? Over.
That's affirmative, Bruce. Once I got her in the drogue, we'd talked among ourselves, and we told Al to hold off until I'm thrusting and I'm satisfied with the alignment. So when we made contact and I thrusted, and it looked like everything was good, and I held a positive plus X all the way until we got the latches.
Okay, now from contact, when you started thrusting plus X, did you feel anything after the initial contact that would indicate that you'd moved on in and seated the probe in the center of the drogue? Specifically, do you feel that at the time that you selected retract, the probe head was in such a position in the drogue that you should have already been in a barber pole position on the talkbacks? Over.
Well, Bruce, the probe was obviously in the drogue, but there's no way of knowing. But the feeling among us here, and my feeling is that no, I don't think we had capture latch lock until after we went to primary. Now, I'm sure y'all have looked at it, and you've got people down there tearing a probe apart, but I don't even know if it's physically possible, but I don't feel that we had any capture latches in that hole until that last operation when we went to primary and drove the beauty in there.
Okay, do you feel like the probe head was in such a position? Do you feel like the position of the probe head changed on you any after you went to primary?
No, I was watching the limb. I was plus X, and Al called primary, and we started closing on it, and there was no movement,
Okay, we copy no movement after you started the the plus X and got yourself seated in there until such time as the bottle fired. That is no more closing movement. Is that correct?
That's affirmative. As far as I can, tell, we were there, thrusting, holding steady. Okay, do you read me, Bruce?
Roger, reading you loud and clear, Stu.
Okay, and we're sitting steady in the drogue, plus X, everything looking fine. We hit the retract switch, and we start moving together. I didn't hear anything nor see any action until we heard the latches close.
Roger, but while you were sitting there, then the talkback was gray, and then 3 seconds after you went to primary, approximately, it went barber pole, and the nominal sequence started.
Well, I was looking at the talkbacks, and that's about the only thing we saw. As we pointed out before, about 3 seconds after the initiation of the primary contact, the primary retract switched to the number one position. They went barber pole for perhaps a quarter, half a second, and then they went gray simultaneously with a hard dock.
Roger.
Hey, Bruce?
Go ahead, Stu.
Okay, and on that one now, we sort of have lived out. I guess it's something we need probably going to get to, but we yesterday, we called it a ripple fire, and we felt like we had them all, which we did. But it really felt like the latches. We got a couple, or it's hard to say how many, but we got some latches, and then in some discrete time, maybe a quarter a second or something like that, then we got the rest of them in a ripple. So I think we got the docking latches in two distinct times, separated by, a very small amount, but at least it was enough to say it was not one continuous ripple fire.
Okay, Stu, we copy that, and I guess one last point on this final docking sequence. Did the closure of the two vehicles start when you selected primary and continue for some period of time with the barber pole indication appearing during this period of closure, or did the flash to barber pole and then back coincide with the beginning of the closure for hard docking?
Hey, let's talk about that one a second, Bruce.
Roger.
Bruce, let me give you my opinion from the right seat. We're coordinated, I think, on the way this happened. I saw us move in as previous attempts. We had moved just a little bit to improve alignment as the drogue forced the probe toward the center. And we started to bounce. It looked like we started to bounce back out. Stu hit the plus X thrust and held it what appeared to be right in the middle of the drogue with thrust. He called the retract. Al hit the retract, and a moment after that, it seemed like we started to move together. Al then called barber pole, called gray, and we were moving together continuously during this time, and then I heard the fire go off of the latches making.
Okay, we copy that, Ed. Thank you.
No, we did not.
And I wonder if you could comment on the thrusting activity immediately after contact for each docking.
Okay, as I said, on the first one, I was going along
I think we're
expecting it
we're referring more to any sort of stable attitude control or stabilization thrusting other than the plus X. I think you've pretty well covered the plus X for us.
Oh, that's the only thrusting I did. That's all it took to align it. I did no other movements either with the RHC or the THC after contact except plus X.
Okay, we copy that.
Bruce, the probe was sufficiently close to the center of the drogue on each of those contacts. I believe that the marks we pointed out to you on television yesterday represent the
the initial contact to the probe. It could not have been more than 1.5 inches or 2 inches from the center of the drogue at that time on any of the contacts.
All right, it looked like Stu was right in there in the center from what we could see on the TV last night on those contacts.
That's affirmative. It looked the same way up the right window.
14, this is Houston. In the process of making the docking yesterday, we advised you to check some circuit breakers, which you did. Did you at any time cycle any of these circuit breakers, that is, open and then reclose them? Over.
Okay, all we did was check them. That's the Group 4 and the docking probe circuit breakers. I just checked them, by pushing on them, but no, we did not pull any and then push them back in.
Okay, we copy, and that about winds up our queries on the docking probe situation, and we'll be ready to go on the launch vehicle debrief here in a minute or so.
Okay, Bruce.
Okay.
14, Houston.
Go ahead, Houston.
Roger, last night on the docking probe removal, after you took the preload off the probe, could you tell whether the probe head was in fact locked into the drogue at that time or not?
No, it appeared to be, Bruce. I took the preload off, and in fact, I think Al made that question, and we both looked up around at the probe head to see if we could see anything that looked unusual about it, or whether it looked like it was out or anything, and it did not. Everything looked normal.
Could you feel and tell whether the head of the probe was locked into the drogue or not?
No, I guess the answer to that would be we don't know. But now I guess as you realize after I collapsed the probe, it definitely was.
Okay, you say after you collapsed the probe, the head of the thing was definitely locked in there.
Yeah, it was hanging in there, and I had to apply a little tug to get it out. I went right by the decal on the checklist, and I think you asked at that time about the force that it took to bring it out, and it appeared reasonably normal for the first time that I had done it in 0G. It didn't appear to be anything funny about it. Yeah.
Bruce, let's make it clear. There is no question about the capture latches being through the drogue, but the question of whether they were locked or not is one we don't know the answer to.
Right, that, of course, is the question that we were trying to get at here just now. Apollo 14, this is Houston. At GET of 28 hours and 30 minutes, you are approximately 1,180 nautical miles. That's 1180 nautical miles away from the S-4B. If you'd care to look for it, we suggest you use a P-52 program with a star code of 0 and load the following numbers in Noun 88 if you're ready to copy.
Go ahead.
Roger. Noun 88 values. R1 minus 31505 minus 87189er minus 37491. Read back over.
Okay, we'll plug in minus 31505 minus 87189er minus 37491.
Roger, your readback's correct, and we'll probably, at the end of the launch vehicle systems debriefing here, have some more numbers for you if you want to, if you don't acquire it on this first pass.
Okay.
And we're ready to press on with the debriefing. If you've got your flight plan handy, you can just proceed down through the questions, and we'll interrupt if we find anything that's unclear, or if you'd prefer, I can ask them to you in panel discussion type thing, and you can answer back. Over.
We'll go ahead with the flight plan. Stand by 1 minute.
Roger.
Okay, Houston, on question number 1 regarding significant changes in noise level. The only change in noise level we noticed was during the first part of the launch on S-1C, when we had the initial noise of ignition and the build-up in noise during max Q. And, of course, the associated
14 Houston, I think we're coming up on an antenna switchover point. You seem to be fading down into the mud.
Okay. You reading now, Houston?
Okay, we're reading you better. Signal strength-wise, Al, we still seem to be getting a little bit of breakup from your comm carrier. Can you reposition the mic, see if that helps any?
Okay, I have the mic right in front of my mouth right now. Is that better?
Roger. I think we better take it from the top again.
Okay, from the top. The only significant change in noise level we noticed was that associated with the burning of the engines in the atmosphere. That is the ignition, of course, build up of noise there. And the noise level increased through max Q, and then a drop-off. Other than that, with respect to the noise itself, we had no problems at all in our communications at any time during the stages of the plane. Does that satisfy everybody on question number 1?
That's affirmative. Press on.
Okay, number 2. On the F1C, we noticed no significant changes in noise level and vibration. Other than what we just discussed. F1C we felt was a real fine ride, nothing unexpected. The F2, we noticed a change in vibration, or sort of a slight pogo, which started at 8 plus 40. Nothing really of any great magnitude. And on S-4B to orbit burn, we noticed no significant changes in the noise or vibration level. We noticed nothing unusual on S-4B during TLI ignition. However, we did notice beginning of a slight hum, low hum, or buzz toward the end of the TLI burn. That's it for number 2. Any questions there?
We have no questions right now on that, Al. We're closing our loop down here with the Huntsville Operations Support Center, so it takes us a few seconds to a minute or so to get a response back. Why don't you press on with question number 3, and if we get any queries, why, we'll reopen the previous ones.
Okay, on number 3, nothing unexpected in the way of transit that on which we had not been briefed. As a matter of fact, it went pretty much according to the way we had expected it. So all of the events mentioned in question We did experience a little more abruptness with the cutoff of S2. The S2 Seco, I think we came out of Dodge a little more than we expected. Otherwise, everything was pretty much the way we'd kind of planned on it. Question 3.
Roger. Question 4.
Okay, Stu's ready for you on question 4.
Okay, Bruce, I got a good look at that shroud. Of course, station keeping with the S-4B, and you couldn't see all of it, but as we moved around, you could see a good portion of it back around behind the limb, and every place that I could see, and Ed also, and Al was looking through the hatch windows part of the time, and everything looked just tight as a drum. We saw no loose pieces of the shroud anywhere, nothing out of the ordinary. And after SEP, after ejection and the booster came into view, came into my window, pretty much of a head-on view, and we were out a little ways, but there was no visible damage at all to the shroud at any time. And like I say, I think we got a real good look at it the time we spent around it.
Roger, we copy.
Okay, going on to number 5. We experienced good communication throughout the entire powered flight and launch. All of us were able to hear the ground on all the calls, and we had no comm problems at all.
Roger.
How about you? Did you have any comm problems from us? How about you? Did you have any comm problems from us?
Negative. We experienced no comm problems.
Okay, question number 6 about the visible bending. Stu, you want to cover that?
Okay, we didn't see anything unusual other than those that you called. And when you called the venting while we were station keeping, well, of course, it came on, rather beautiful sight. And the only other thing was when you gave a mark for the apps evasive burn, why I noticed the booster venting, and it appeared to be the same area as it had been venting during the station keeping phase, and the answer came back that that was expected and so forth, and that was the only thing out of the ordinary. Other than that, everything was fine, and all the other vents you called.
Okay, on to number 7. And I guess that one may still be open.
Yeah, I was just trying to whip off a fast answer for you on that one, but we don't have any. So I guess Al will tell you the last time that we saw it.
Well, I guess the last time we saw the 4B was with the eyeball. Thank you, that is. And it was during the propulsive bending. It was kind of a tough angle for us to see because of it was just very low on the edge of window number 1. However, the turning on it was good. It was stable when it was bending. Near as I could tell, approximately a couple of miles away. We took a few pictures of it with a Hasselblad, so we may be able to see the beautiful conical shaped pattern coming out of the vent. But as far as control was concerned, it was going in the right direction and appeared to be stable.
Roger, we copy.
Okay, number 8. Who you want to take that one?
Okay, I guess the guidance obviously was good, and the velocity was real fine. It looked like during the boost phase, they were running maybe 2.5 miles, maybe 3 miles low along my profile. Looked rather consistent, but we obviously arrived at the right place. So and the velocity cutoffs were right in the money, and the TLI guidance I think was Said it's been 10 feet, 17 or something like that. You've got the numbers, but it looked real good. And the only thing I can comment there was it looked to me like we were going into Earth orbit insertion, maybe a couple, 3 low, pretty much on the profile.
Roger.
All the way on the profile, I should say.
Okay, you ready for number 9?
Roger, go ahead with number 9.
Okay, the ideal ball at ignition was as advertised at 8.5 degrees. After ignition went to the normal pitch down, the ball locked very close to 0. And then as the burn progressed, eased on up to about a plus 1 degree. Then slowly on back down to 0, and then of course it took the pitch down just prior to the cutoff. And I would say somewhere around 2 or 3 degrees negative, that is 357, 358 with the ball prior to cutoff.
Okay, and we've got one more write-in, question number 10, and it's based on...
Okay, I'll take that one, Bruce.
Okay.
Okay, Bruce, that came from my comment, and as we were station keeping and watching the binning, it looked to me like the booster had picked up a little right yaw as I looked at it. I meant moving left on me. But then I just mentioned it looked like it was moving over a little, but then later on I decided that was just the scatter of the 2 vehicles' deadbands, because the IU or the S-4B deadband all the time was solid as a rock, even during the binning. And after all that binning, when I went back to try the other dockings, I expected to have to change my attitude a little bit, and as it turned out, the attitude was still, right within a degree. So that was just a call that appeared to at that time, but the S-4B vented from both sides, and it was steady, and I think I was just picking up the movement of the deadbands of the 2 vehicles.
Okay, Stu, thank you.
Right.
And while the Huntsville people are closing the loop here, we had previously given you a flight plan update concerning your wastewater dump at 30 hours plus 15 minutes. And our update was that you dumped to 0%. We'd like now to modify that to a nominal dump to 25% on the wastewater. Over.
Okay, we are now modified. 25% it shall be.
Roger out.
Could you tell me about Al's comm? You mentioned some dropouts in EKG prior to launch. Apparently you're still not seeing those. Are they however, associated with these voice dropouts you're talking about today?
Stand by, please. 14, this is Houston. Our belief is that there's no correlation at the present time between your earlier EKG problems and the current degraded comm through Al's comm carrier. We would like to suggest, when you have the chance, that Al try using the spare comm carrier and see if that improves communications.
Okay, we'll shift over.
14, this is Houston. We've received some inquiries regarding your answer to question number 2. The Huntsville operation people would like to get a little more detail on this slight hum or buzz. Was it actually an acoustic or audible noise, or was it felt through the structure of the spacecraft? And can you give us approximately the time that it commenced and duration, that is, did it proceed until TLI cutoff?
on, Houston.
Roger.
Okay, Bruce, I think of course it's kind of hard to describe, I guess, and maybe make ourselves clear, but it definitely was not an acoustic buzz. It was a high-frequency buzz that we felt through the structure, and I'd say it probably started, and this is an approximation, say 2 minutes into the TLI burn.
Okay, and continued through the balance of the burn?
Pretty much so, yes. Just about the same level. I wouldn't say that it increased any significant amount.
I realize this is sort of hard to put your finger on. Is there any way you can quantify the level or give us some feeling for how high the level was?
No, I think that's pretty tough, Bruce. In fact, you know, the burn was going so well and the ride was so smooth that you know, we had time to pick it up. I suspect that you know, it was low enough level that if you had something else on your mind, you wouldn't even have noticed it.
Did this just sort of start abruptly, or did it build up from the background, do you think?
Well, it feels it was a build-up, and I'm not sure, so let's vote that it was a build-up, and that seems to be the majority. Yeah, and it just came on kind of slow and came up, stayed at a low level, and was there.
Okay, and the only other question we got back in is that at 8 plus 40, this pogo type thing that you mentioned was, could you give us a little more detail on the direction of motion of it, and the amplitude, any more elaboration that you have on that would be appreciated.
Okay, I guess I called out the time on that one in the cockpit. It was no doubt but what it was a slight pogo, and I think it was longitudinal, and as far as amplitude, I'm trying to think back to some of those pogo tests I wrote on the shake table, but they were of such high level that I couldn't compare them to this. But it was a pogo. It started just about that time, because when I felt it, I looked at the clock, and it was not a...
14 Houston, we had an antenna change over here, and 14 Houston, how do you read? Houston, how do you read?
Okay, how do you read, Bruce?
Loud and clear, Stu. How do you read me?
Oh, you're 5 square. The statics died down, and as I was saying, there was no question but what it was a low amplitude pogo starting right at 8 plus 40. However, the magnitude was low enough that it was not affected, did not affect any of our voices, and you know, a fairly low level will do that. So I'd say, you know, it was pretty small, was not of any concern, but picked it up just because, you know, thinking about Pogo, I guess.
Roger, thank you. And Stu, did that last all the way until shutdown of the S2, or did it die back out?
Bruce, I can't give you a positive answer. None of us can. My impression is it was there all the way, but that data really isn't a very good input.
Okay, thank you. And I believe this concludes our discussion on the booster questions.
Okay.
Uh, 14, this is Houston.
Go ahead, Houston.
Okay, just a little status on the probe situation. We have no further queries on the docking probe at this time. The conclusions of our ground analysis are that the system is now working nominally, and our current intention is that you'll be go for the lunar landing and all subsequent events. If we have any further commentary or further discussion on the subject, why we'll get back to you later on it. With respect to midcourse correction number 2, we plan for that to take place at the nominal time, which is about 30 hours, 36 minutes GET, and it'll be about 71 feet per second, which is also close to nominal. We are planning a GET update of some 40 minutes tomorrow at the nominal time in the flight plan of about 5440, over.
Okay, we got that, Bruce. And are we going to leave this Earth dark side dim light photography in?
That's affirmative, Stu.
Okay.
Houston, this is Al. I've changed CCU heads. How does this sound? Any better?
Would you give us a short count on that, Al?
Okay, 1, 2, 3, 4, 5, 4, 3, 2, 1. Over.
Roger, that sounds a lot better to me.
Okay, we'll take mine and make it the spare.
Roger. Al, are you using the lightweight comm carrier now, or the Snoopy hat?
Hitting the lightweight in a moment.
Roger, thank you.
Houston, 14.
Go ahead, 14.
Okay, the Delta V check went fine, and on the null bias check had a minus 100 to start, minus 99.6 at the end.
Minus 100 and minus 99.6. And I have your midcourse correction 2 pad here whenever you're ready to copy.
Okay, stand by 1.
Okay, Tate, I'm ready to copy. Houston, follow. Tate, ready to copy the pad.
Go ahead, R14, this is Houston with the midcourse correction 2 pad. SPS GNN burn 64213 plus 102 minus 023 TIG 030 36 0701 minus 00259er plus 00044 plus 00664 roll 282 pitch 354 29er8. Now in 44, NA. Delta V total, 00714. 010. 00665. 25. 2785. 390. The balance of the pad is NA. GDC align, Sirius and Rigel. Roll align, 230 170 002. No ullage. In the burn attitude, S-band high gain antenna pointing angles, pitch -22, yaw 0. Wide beam, manual mode. Lem weight, 33647. Your burn time to the nearest tenth of a second is 10.3 seconds for use in checking ball valve operation. Over.
Okay, I read back in the C2, that's the SGNN. 64213 plus 102 minus 023 030 36 0701 minus 00359 plus 00044 plus 00664 282 354 298 NA 00714 010 00665 25 2785 390. The rest NA. Sirius and Rigel 230 170 002. No ullage. High gain antenna at the burn attitude is pitch -22. Yaw 0. Wide beam and manual. Lem weight 33647. Burn time is 10.3. 103.
Roger, Houston, read back correct.
Thank you.
Uh, 14 Houston, we've had a correction to the yaw angle for the S-band pointing. That should be +8 degrees. Over.
Roger, the S-band pointing is pitch -22, yaw +8.
Roger, out. Roger, we have them, 14.
Okay, and they were torqued at 29 plus 20.
Roger.
This is Apollo Control at 29 hours 23 minutes. During the past 2 hours or so of this shift, shortly after the maroon team of flight controllers came on, we began preparing for the discussions on the probe and also for the scheduled discussions on the booster performance during the powered ascent during the launch phase. During the discussions on the probe, among the comments that were made by the crew, Rusa noted that there appeared to be no capture latches activating until the probe was retracted. Or as he put it, we got no capture latches until we went to primary, at which time the crew activated the nitrogen pneumatic system which retracts the probe. Ed Mitchell summed up the operation on the successful docking. As Mitchell described it, he said Stu Rusa, who was at the controls of the spacecraft, moved in on the drogue. He said we started to bounce out, and at that point, Rusa held +X on the thrusters, moving the spacecraft into the center of the drogue. He said the vehicles began moving together as they activated the primary switch, which activates the pneumatic system that retracts the drogue. And at that point, he said Al called out barber pole and gray, and then we got hard docking. The talkback indicators that Mitchell was referring to indicate initially that the probe is extended and the docking latches, the capture latches, are cocked. The second indication of barber pole indicates that the capture latches have in fact captured and latched. And finally, the third indication of gray shows that the main docking latches have engaged and closed, the hard docking latches. Perhaps the most significant comments during the discussion of the booster were reports from the crew that they noticed a slight hum or buzz, as Rusa described it, during the translunar injection portion of the S-IVB burn. Rusa noted that this very low-level hum or buzz, which he said could be felt through the structure, began about 2 minutes into the TLI burn. He also noted that it was slight enough that had the crew had their minds on other things, they probably would not have noticed it. Flight Director Milton Wendler observed on the circuits here in the control center that this is the sort of vibration or hum that has been reported also by previous crews, and there appeared to be no particular concern over this. Rusa also reported a slight pogo in the second stage operation, beginning at 8 minutes 40 seconds ground elapsed time. He described it as a longitudinal vibration, very light, very slight. The one thing that he used to characterize this vibration was to compare it with similar vibrations the crew members had been subjected to on vibration tables. Rusa noted that with even a relatively light pogo-type vibration in a simulated situation, it's difficult to talk. He said that this was light enough that it did not affect their voices in the spacecraft. The Capcom also advised the crew that at about 54 hours we will have the update to the ground elapsed time clocks in mission control and aboard the spacecraft. At this time, the GET clock, the clock that is currently reading GET here in mission control, will be updated. It will be moved ahead some 40 minutes. The clock that is currently designated TB5 will become the actual ground elapsed time. In other words, that clock will display the true ground elapsed time, the total amount of time that has elapsed since liftoff. The clock, which is designated GET, will retain that designation. The nomenclature will remain the same on that clock as it's displayed here in the control center, and the nomenclature on the clock, which will be displaying the actual GET, will remain TB5. To repeat that again, recognizing that it's probably a bit confusing, the nomenclature on the clocks will remain the same. However, what they're displaying will be changed. The clock that is designated GET will actually be referred to here in the control center as the PET clock, the phase elapsed time clock. However, the nomenclature on it, as we understand now, will not be changed. It will remain fixed as the GET clock, and the nomenclature on the TB5 clock will also remain TB5. However, it will be counting actual ground elapsed time, the total time since liftoff. The rationale for the update to the clocks is roughly as follows. Of course, launching 40 minutes late without changing the amount of energy that was put into the trajectory by the translunar injection maneuver with the Saturn third stage, we would have arrived at the moon 40 minutes late. However, the translunar coast phase is in many respects like a big sponge. You can squeeze things out of it, or you can put things into it, use it to absorb time differences. And in this case, at translunar injection, the proper delta V, the proper velocity, was added to put us into lunar orbit at the same sun time or Greenwich Mean Time as the flight plan called for. The sun time on arrival then will be the same as it was originally planned to be in the flight plan, and mission events will occur in the same sequence after lunar orbit insertion as the flight plan called for. In order to make the flight plan agree with the sun time and the Greenwich Mean Time, it will be updated 40 minutes. The clock will be moved ahead 40 minutes so that the phase elapsed time, which is used as a reference to the flight plan, will agree with the flight plan. The alternative to this would be to update the flight plan by 40 minutes, making numerous changes to the flight plan in pencil, both here on the ground and by the crew. To circumvent this problem, the clocks themselves will be changed, recognizing that the clocks are, in fact, the GET clock is, in some senses, an arbitrary time reference, which allows us to reference time to the flight plan. The crew was advised this event will occur at about 54 hours as planned in the flight plan. At the present time, Apollo 14 is traveling at a velocity of 4,536 feet per second, and the spacecraft is 115,742 nautical miles from Earth. The mid-course correction number 2 is scheduled to occur at 30 hours, 36 minutes, 7 seconds ground elapsed time. The velocity change in that maneuver, which will be performed with the spacecraft service propulsion system engine, will be 71.4 feet per second. And it will change the spacecraft approach to the moon, the point of closest approach, from the current distance of about 2,104 nautical miles down to the planned 60 nautical mile perigee or paraloon. The burn will be a 10-second maneuver, a 10-second burn with the surface propulsion system engine. The spacecraft at the time of the maneuver will be oriented with its engine bell pointed in the direction of travel. About 66 feet per second of the burn will be in the direction pointing back to Earth, or in other words, it will be radial, a radial component, and 25 feet per second, there will be a 25 foot per second component, which is retrograde, or in the easterly direction. The total composite delta V, as I said, will be 71.4 feet per second. At 29 hours 34 minutes, this is Apollo Control, continuing to stand by.
Apollo 14, this is Houston.
Go ahead.
At your convenience, we'd like poo and accept, and we'll uplink you a new state vector, target load, and the PIPA and iRig bias updates. Over.
Okay, you have it, Houston.
Roger. They're on their way. And at the same time, we'd like to give you one minor flight plan update. Due to your later liftoff time on page 332 of the flight plan, dark side dim light photography, we have a new value of longitude over 2 for you.
Okay, go ahead.
Roger. Old value is minus 42500. New value minus 47500. Over.
Okay, longitude over 2 is now minus 47500.
Roger, and I've been asked to remind you that in connection with the Midcourse burn number 2, if there is stratification in the oxygen tanks, you may get a cryo low press light as this is reduced. Over.
Roger.
"14 Houston, your computer."
Houston 14, are you finished with your uplink?
14, affirmative. How are you reading us now? We passed up. Computer's yours.
Okay, I guess we must have missed it during an antenna switch, and we're terminating PQC here in about 2 minutes.
Roger, out.
Okay.
Houston, Apollo 14.
Go ahead, Ed.
We see it down 80 months, Delta B by 1/10 dip pad, which is correct.
14 Houston, we understand the onboard value is correct. And that's an R2 that you're concerned about?
Yeah, we've never seen down 80 months ground off like that.
Okay, we'll have an explanation for you in a second.
Okay.
Houston, Apollo 14 Houston.
Go ahead.
Roger, on your query on noun 81, 4.3 is the number that was actually uplinked to the spacecraft. There is no problem involved with the spacecraft rounding off numbers or anything of that sort. The maneuver that was passed to you on the maneuver pad was generated from one computer reading a 4.35, which was rounded upwards by the FIDO to 4.4. A separate computer processed the information leading to the automatic uplink, and they rounded down to 4.3. Over.
Okay, those computers ought to talk to each other.
Roger, out. This is Apollo Control at 30 hours, 6 minutes. Apollo 14 at this time is 117,213 nautical miles from Earth. The spacecraft velocity 4,483 feet per second. About 2 hours ago, an auspicious event slipped by unnoticed as the spacecraft passed the halfway mark in terms of total mileage, or in terms of mileage to the moon, I guess we should say. At 27 hours, 4 minutes, 42 seconds, Apollo 14 was 109,172 nautical miles from Earth, or halfway between Earth and the moon. The spacecraft velocity at that point was 4,779 feet per second. We'll cross the halfway point in time on the trip to the moon,
at 40 hours 56 minutes. Both the distance and the time halfway point are dependent upon a normal mid-course correction 2, should that MCC2 maneuver, which is scheduled to be performed in a little less than 30 minutes, give us different values. It would, of course, change the total distance by some small amount. The flight dynamics officer has also computed a new set of coordinates and a new time for the arrival of the S-4B at the lunar surface. The impact is scheduled to occur at a ground elapsed time of 82 hours, 38 minutes, 3 seconds, and our new set of coordinates are as follows. The latitude of the impact point now appears to be at 9 degrees, 32 minutes south, the longitude 26 degrees, 20 minutes west. What we're seeing is a gradual shift of the impact point slightly to the west and moving a bit closer to the Apollo 12 seismometer. Again, to repeat the information on the scheduled mid-course correction, which is occurring at the second mid-course correction opportunity. It will be the first mid-course. The burn is scheduled to occur at 30 hours, 36 minutes, 7 seconds ground elapsed time. The burn duration will be 10 seconds, and it'll be performed with the surface propulsion system engine, giving a total velocity change of 71.4 feet per second. And the bulk of that velocity change will be in a radial direction or back towards Earth. And the effect of the maneuver will be to bulge the trajectory slightly so that the spacecraft arrives at the moon a little later and also at the planned altitude of 60 nautical miles. Without the burn, the spacecraft would pass by the moon at an altitude of 2,104 nautical miles, and it would arrive 40 minutes earlier. With the burn, it places the arrival time back 40 minutes to coincide with the ground elapsed time, the Greenwich Mean Time. Correction on that, the time of arrival is fixed by the cutoff conditions of translunar injection, the mid-course correction burn, taking into account the fact that we will be arriving at the moon at the planned Greenwich Mean Time, will depress the trajectory so that the fly by the moon prior to going into lunar orbit is at 60 nautical miles. And we're now 25 minutes, 54 seconds away from that mid-course correction maneuver. The maneuver, in addition to lowering the distance at which the spacecraft passes by the moon, will also remove the spacecraft from a free return trajectory in at least one sense, and that is that following the burn, it will no longer be possible to re-enter the Earth's atmosphere in the proper entry corridor using only RCS propulsion capabilities. Once this mid-course correction has been performed, in order to enter the entry corridor properly, it will require either subsequent mid-course corrections using the SPS engine or the descent propulsion system engine on the lunar module. At 30 hours, 11 minutes, this is Apollo Control Houston standing by.
14, this is Houston.
Go ahead, Houston.
Roger, Stu. We're looking at your DSKY display here, and notice it's a little different from the pad burn attitudes. We believe that if you go back and reload noun 48, with the pitch and yaw trim values that we sent up on the pad, which are for the combination CSM LEM, and then redo P40, you'll get better agreement with the pad values for attitude.
Okay.
This is Apollo Control at 30 hours 17 minutes. We now show the spacecraft to be in the proper attitude for the mid-course correction. I would like to go back over one point that perhaps got a bit garbled in the last report, and that is the effects of this maneuver on the trajectory. Without the burn, without the mid-course correction, the spacecraft, as we said, would pass about 2,104 nautical miles from the moon. Also, its time of closest approach would be about 15 minutes later than desired. With the mid-course correction, we place the time of approach at the time desired, which is 82 hours, 0 minutes, 37 seconds. That would be the time of closest approach with no further maneuvers. And we lower the point of closest approach from the 2,104 nautical miles to 60.3 nautical miles. We're now about 17 minutes, 30 seconds away from that mid-course correction maneuver.
Oh, 14, this is Houston.
Go ahead, Houston.
All right, Roger, you can go ahead and terminate charging on battery alpha at this time.
Okay.
Uh, 14 is Houston. We're in position, standing by for a go for MCC2 burn.
Roger, your go.
Roger.
This is Apollo Control at 30 hours, 35 minutes. Flight Director Milton Wendler has just reminded his flight controllers that we're 1 minute away now from our first mid-course correction. Maneuver scheduled to occur now in about 45 seconds. The flight controllers here are monitoring their data, and we'll be observing the performance of the service propulsion system engine and spacecraft systems during the period of this burn. Total burn duration again is planned to be about 10.3 seconds. It'll give us a change in velocity of 71.4 feet per second. Coming up on 10 seconds. And we show ignition. Our guidance and control officer reports all pressures in the engine look normal. And we show the burn has been shut down. We'll stand by for an assessment of the maneuver.
That was a mighty good burn there, the residuals, be no trim required.
Roger, out.
And you heard Stu Russo report a mighty good burn. No necessity to trim out the residuals with the RCS. And our guidance and control officer reports that the burn duration was an even 10 seconds, which is almost precisely as planned.
Uh, 14, for your information, we showed the actual burn time to be 10.0 seconds over.
Our telemetry data. Our telemetry data shows that the spacecraft onboard computer.
Great. The CMS was never like that.
Roger.
Houston, at the end of the burn, we're showing fuel 002, oxidizer 9er, unbalanced 300 decrease.
Okay, I understand fuel.
And Delta VC. And Bruce, Delta VC minus 4.1.
Okay, Delta VC minus 4.1, fuel 100.2, oxidizer 98.9, and unbalance is 300 decrease. Is that correct?
That's affirmative. And if you didn't get the residuals, they're plus 0.2, minus 0, and minus 0.1.
Roger, we copy.
Our telemetry data showed that the onboard clock timed that burn at 10.19 seconds, which is extremely close to what we showed on the ground, our reading being 10.0 seconds. You heard Stu Rusa comment that the simulator was never like this, a reference to the fact that the onboard guidance system controlled that burn almost precisely as planned. The flight dynamics officer will begin at this point to gather telemetry data on the trajectory to compute a trajectory arc and determine what effect the maneuver had on the trajectory. This is a process that normally requires several hours before the data becomes refined and the flight dynamics officer has a good, stable prediction on the effect of the maneuver. He'll have a preliminary report somewhat before that, usually in a matter of 15 to 20 minutes.
Uh, 14, this is Houston. We've reviewed the chamber pressure and the SPS engine operation from this last mid-course on the strip charts, and it looks real fine. We'll have some more words for you later on the reconciliation of the burn times in tenths of seconds. We're curious as to what value you got with your stopwatch. Over.
That showed about 10.2, Bruce.
Understand 10.2, over.
That's firm.
Hey, Bruce, what do the strip charts show as PC, 2 banks?
We're going to have to convert from percentage of thrust to PSI, Stu. We'll be right at you.
Oh, no sweat. I don't cause you any trouble. I was just curious.
No, they're doing it anyway, just so we hadn't gotten it accomplished for this burn yet.
Okay. Just wanted to calibrate my gauge.
I might check your middle gimbal angle, Stu, for the maneuvering.
Raj, we're eyeballing it.
.14, this is Houston. For your information, when starting the PTC spin-up, we'll use quads Alpha and Delta, over.
Okay, we'll use Alpha and Delta for the spin-up.
14, this is Houston. Your average chamber pressure for this last burn was 100 psi even.
Okay, the average was 100 even. Thank you.
Roger that.
Houston, 14.
Go ahead, 14.
Okay, Bruce, tell you, I'm sure not seeing what I expected to on this dark side of the Earth through the sextant here. The angles that you gave me lined up the optics pretty much over on the edge of the dark side, all right. But through the sextant, there's still a lot of light coming in, and with that high-speed black and white, I don't see why we're not going to wipe it out. I guess I really expected to see pretty much darkness through the sextant here.
Okay, stand by.
Okay. And there's another strange thing on the sextant on this sighting, Bruce. We got
stand by.
Got it. Okay.
This is Houston.
Go ahead, Houston.
Well, Roger, we've been advised that there was some illuminated area of the Earth expected to be visible in the field of view for this dim light photography. What we'd like you to do is to go ahead using the nominal angles, take your 3 exposures, and then if it's agreeable to you, we'll have a new set of shaft and trunnion angles for you, and you could squeeze off 3 more. Over.
Okay, no sweat. I'll press ahead and take some photos.
Roger, press on.
Mm-hmm.
14 Houston, in your original transmission, did you say that you could see any of the illuminated portion of the Earth through the sextant eyepiece, or just that you had some scattered light coming in? Over.
I've got quite a bit of scattered light. It's negative on seeing any of the lit portion. I manually, I've driven it over to the terminator, and then the CMC pulls it back to the dark side. We're pointed on the dark side, but there sure is a lot of light showing.
Okay, we copy.
Okay.
14 Houston, have you already mounted the camera on the sextant adapter, or to the sextant?
That's affirmative, Bruce. I'm in the middle of the first frame right now, but it's no sweat to change. I can do anything you want.
No, don't do that, because we'd have to squeeze off more film at 24 frames per second prior to dismounting it.
Okay.
This is Apollo Control at 31 hours 26 minutes. As you heard, Stu Rusa is preparing to use the Maurer sequence camera, 16 millimeter data acquisition camera aboard the spacecraft for the dim light photography scheduled in the flight plan at this time. Rusa will have the camera mounted, or actually has the camera mounted at this time, to the sextant of the spacecraft. Uses the spacecraft computer to point the optics in the proper direction, which in this case is at the Earth dark side, and he will take 3 frames. One.
I finished the 1 minute, the 20 second, 5 second exposures, and I'll just hold here until you give me some more angles if that's what you want.
Okay, Stu, what we'd like you to do is in your longitude over 2 for P22, just put in minus 42.5, which was the value that was originally in the flight plan before we updated you, and run 3 more exposures, and that'll wind it up.
to like it was originally in the flight plan and repeat.
Roger out.
That last comment came from Apollo 14 Commander Al Shepard. Rusa took the first three frames, one exposure at 60 seconds, one at 20 seconds, and one at 5 seconds. These pictures taken with very high-speed black and white film are hoped to show some of the phenomena on Earth that are visible only in very dim light, such as lightning. And as you heard, Rusa will now repoint the optics and take 3 more frames of the same phenomena at a slightly different pointing angle. Hopefully one of the 2 angles will give a minimum of reflected light into the optics. The reflected light, of course, tends to wash out the amount of detail that's visible.
Okay, Bruce, I completed the pictures. I put the sextant back on and looked at our second one, and it's going to be just about the same.
All right, Roger, Stu. I think that wraps up the requirements for the dim light photography.
Right.
And just to clear up the situation that I created on giving you a quad alpha delta, we are recommending alpha and Charlie for the PTC spin-up, and your option on the quads that you use for rate damping.
Okay, we figured that's what you meant.
This is Apollo Control at 31 hours 42 minutes. The Apollo 14 crew has completed the dim light photography scheduled in the flight plan. The next event will be to stabilize the spacecraft and then spin it up at the relatively slow rotational rate of 3 revolutions per hour. This is the passive thermal control mode used to maintain the proper thermal stability, the proper temperatures of the spacecraft, exposing all sides of the spacecraft equally to the radiation from the sun. At the present time, we show Apollo 14 121,264 nautical miles from Earth, traveling at a velocity of 4,271 feet per second. The preliminary data from that midcourse correction maneuver, performed at 30 hours, 36 minutes, 7 seconds, as called for in the flight plan, is that the delta V gained, the velocity resulting from the maneuver, was 71.4 feet per second. And the preliminary tracking data shows that the maneuver had the effect of lowering the point of closest approach to the moon from 2,104 nautical miles to 67.05. The maneuver was targeted to lower the point of closest approach to about 60 nautical miles. And the flight dynamics officer reports that with additional tracking, we expect the data to show that we came very close to that. The burn was almost precisely normal, as planned. The burn duration had been targeted for about 10.3 seconds, and on the ground we measured the burn time at 10 seconds. Of course, the guidance system on the spacecraft is designed to shut down the engine based on the amount of velocity gained rather than the time of the maneuver, rather than the time of burn, so that it's perfectly consistent for the guidance system to shut down within a fraction of a second or a second of the pre-computed time based on the amount of energy that is gotten from the engine in any particular maneuver. During the burn and for about 1 hour before, Louise Mitchell, wife of Lunar Module pilot Edgar Mitchell, was in the control center viewing the procedures. We don't have a great deal of activity scheduled on the flight plan now. The astronauts are scheduled to begin another sleep period at 41 hours, or about 9 hours 15 minutes from now. During the interim period of time, primary activities will be systems monitoring and such things as charging batteries, venting the batteries, and of course setting up the passive thermal control mode, which will be beginning soon. Earlier this evening, we again talked with the crew about the condition and the events preceding and leading up to the docking operation and the condition of the probe assembly. Following the crew's answering some additional questions about the probe assembly, they were advised that the probe appears to be normal and that we will continue with the normal flight plan leading up to a landing on the moon as things stand right now. The Saturn third stage, the S-IVB, based on our last computations, will impact the moon at 82 hours, 38 minutes, and 3 seconds at a latitude of 9 degrees, 32 minutes south, longitude 26 degrees, 20 minutes west. And as we continue to gather more tracking data, these numbers have been changing, and we expect that they will continue to change somewhat. At 31 minutes 47 seconds, this is, rather 31 hours 47 minutes, this is Apollo Control Houston standing by.
Apollo 14, this is Houston, over.
Go ahead, Houston.
14 Houston, you can secure the high gain antenna at this time. We recommend a pitch of minus
Go ahead,
5.
Bruce.
We recommend a pitch of minus 52 degrees, yaw of 270 for securing the high gain antenna. Request Omni Bravo for PTC, over.
Houston, Apollo 14, we're reading you loud and clear. Go ahead.
Apollo 14, this is Houston. You may secure the high gain antenna now. Pitch minus 52. Yaw 270. Request Omni Bravo for PTC, over.
Houston 14, that's what you have.
All right, Roger. Apollo 14, this is Houston. Stand by for an important announcement. Roger, you're go for PTC spin up now.
What would we do without you, Bruce? Hey, Bruce, how come we haven't heard any news, like who won at Daytona and things like that?
Well, we tried for one news summary, and most of the news came out to be on the subject of Apollo 14, but we figured you guys were probably the ones that had the inside scoop on that, so we'll give a stab at another one.
Yeah, tell us what's going on at the races at Daytona.
Okay, give us a couple minutes, and we'll have some word for you.
Oh, no sweat, just at your convenience.
Apollo 14, this is Houston.
Go ahead, Houston.
If the workload isn't too heavy up there for you, we've got another set of noun 88 values for sighting on the S-IVB, if you're interested.
Okay, stand by, I'll copy that. Okay, Houston, go ahead.
Roger, 14. Noun 88. Minus 34293. Minus 85901. Minus 38013. Over.
Okay, Bruce, you back with us?
Yeah, I'm still with you. "14, Houston, how do you read?"
Hello, Houston, how do you read 14?
14, we're approaching an antenna switchover period here. Let me give you a call again in a minute.
Hello, Houston, how do you read 14?
14, Houston, loud and clear. How me? Over.
We're back with you. How about giving me R3 again, please?
Okay, R3 is minus 38013. Read back. Over.
Okay, reading you back some noun 88. Minus 34293, minus 85901, minus 38013.
Roger, read back correct. These are calculated for a GET of 32 hours 45 minutes, but should be valid from the present up through about 33:45. You will be able to see the S-4B when your spacecraft roll angle is between 85 degrees, that's 085 degrees, and 020 degrees. If you do see it through the sextant, we'd like you to try to take some pictures using the same techniques as on the dim light photography for camera advance, same film magazine, the same exposure times, if you concur. Over.
Okay, sounds great. I understand this is set up for a time of 32 plus 45, 00. However, it ought to be good now, and we ought to be able to hack it when our roll is between 085 to 020. And if we lamp the big moose, we'll take some pictures of it using the same magazine and the same procedures as the Earth dim light that we just finished.
Roger, roger. Oh, 14, this is Houston. Be advised that the S-4B is tumbling at a rate of one tumble, that is one 360-degree tumble, about every 4.5 minutes, so that the intensity of the object may vary if you see it out there. And even if you don't, we've been considering the speed of the film. We'd like to take some pictures. Perhaps it would show up on the photography if you can't see it with the naked eye. And as another item, your phase plane plot for PTC looks like you've established a very good PTC here. It's curving back around toward the center. We think it's going to hold for quite some time. And we'd like to get battery alpha on charge at your convenience. Over.
Okay, Bruce, copy that. When we get around to the right roll angle, we'll give a go on the S-4B. Copy about the PTC, and we'll start a charge.
Roger. Do you see anything out there, Stu?
Well, we're just now coming out from behind the limb. Looks like I've got something here in the sextant. Let me pull her in the center and see what it looks like. Well, Bruce, I've got two things in the sextant, and it could either be a faint star. I don't see any tumbling on them yet, but 4.5 minutes isn't that fast either.
Roger, we copy.
Okay, I've lost one of them due to light coming into the sextant.
about to lose the other object, whatever it was.
14 Houston, we got a little sports news for you.
Okay, go ahead.
Oh.
You're just in time for dinner.
Would you rather I croon something soothing to you, like background music or Ravel's Bolero or something?
Negative on the music. We got all that we need here. You can just croon some good sport news.
Why don't you hold on a minute, let Ed get his headset on.
It's not that detailed.
Okay, everybody's on the line.
Okay, I don't know if it was really all that earth-shaking. I've got the results of the Daytona races. It was won by Pedro Rodriguez from Mexico with his partner Jackie Oliver in a Porsche, and they completed 688 laps of the 3.81 mile course there at Daytona in 24 hours. Ronnie Bucknam and Tony Adamowicz were second in a Ferrari, and the Mark Donahue David Hobbs team was third. In winning the event, Rodriguez and Oliver averaged over 109 miles per hour for the 24-hour period. In Sunday's Andy Williams San Diego Open Golf Tournament, Californian George Archer took the honors with a 7-under par score against his closest competitors, Dave Eichelberger and Jack Nicklaus. Archer ended up with a $65,000 and $30,000 in prize money. Over.
Okay, very good. Thank you. Keep up the good news.
Roger, you can tell Ed to take his headset back off now.
This is Apollo Control at 33 hours 10 minutes. We're at a relatively quiet period in the flight plan. The crew is scheduled to begin a rest period at about 41 hours ground elapsed time. At the present time, we show Apollo 14 124,800 nautical miles from Earth, traveling at a velocity of 4,149 feet per second. The flight dynamics officer reported to the flight director a short while ago that tracking seems to be confirming that the mid-course correction maneuver is bringing the spacecraft in a little bit higher above the moon than had been planned. This would indicate a slight underburn. The predicted point of closest approach at this time is still holding quite close to 37, or rather 67 nautical miles. The burn had been targeted to bring the spacecraft to within 60 nautical miles at its closest approach. This particular burn seemed to have been quite sensitive to very small velocity errors on the order of about 0.2 of a foot per second would, the FIDO says, account for the difference in the planned altitude and the actual at 7 nautical miles. Additional tracking, of course, will probably show some change in that number, but it seems to be holding in quite steadily at about 67 nautical miles. The people in the spacecraft engineering support room report that all systems appear to be functioning well at this time aboard the spacecraft. Virtually no problems of any significance. And as we mentioned earlier, the crew was advised this evening that with the probe, with what we know about the probe at this time, it appears that the mission will be go for a lunar landing. At 33 hours 12 minutes, this is Apollo Control standing by. This is Apollo Control at 33 hours 31 minutes. We've We've had no conversations with the crew since our last report about 30 minutes ago. At the present time, Apollo 14 is 125,649 nautical miles from Earth, and the spacecraft velocity is 4,121 feet per second. We're preparing for a shift handover in mission control at the present time, and we do anticipate having a change of shift briefing in the MSC News Center, probably in about 45 minutes to an hour. Flight Director Jerry Griffin is coming on to relieve Flight Director Milton Wendler, and the capsule communicator on the upcoming shift will be astronaut Fred Hayes. At 33 hours, 32 minutes, this is Apollo Control, Houston.
Oh, 14, Houston. Roger, we took up a collection here in the control room and bought a newspaper. We got a couple more items if you're interested.
Okay, great. Pick up another collection, you might find two.
Oh, we'll buy you a morning paper too a little later. On the Daytona race, got a few more details. Reading into the article, Rodriguez and Oliver divided the driving chores up about equally.
Hold it a second.
Roger.
Okay, Bruce, what's on the net now? Proceed.
Okay, stand by. Oh, 14, Houston.
Go ahead.
Roger, back in the Daytona, says that Rodriguez and Oliver divided. "14 Houston, how do you read now?" Apollo 14 Houston, how do you read now?
Loud and clear, Bruce, go ahead.
Okay, let me try it once more with vigor. Back in the Daytona race, Rodriguez and Oliver divided up the driving chores about equally and had built up a lead of 213 miles at one point in the race. But trouble struck with about 3 hours left when the car's transmission failed as Oliver was motoring around with not a care in the world. Two Ferraris, the one driven alternately by Bucknam and Tony Adamowicz of Wilton, Connecticut, and another under command of two-time U.S. road racing champion Mark Donohue and David Gobbs of England, had survived the long night, but were out of it as long as the Porsche held together. Oliver brought the powder blue car into the pit, and he and Rodriguez spent an agonizing 93 minutes watching their lead wiped out as crewmen feverishly made repairs. Bucknam gained the lead 70 minutes from the end, and Donohue pulled into striking distance before crew chief John Wire could get the Porsche rolling again. Rodriguez bolted back to the course a half mile behind Bucknam, whose Ferrari was spitting fire and having trouble getting through the turns. The Mexican hotshot needed less than 2 laps around the 3.81 mile layout to catch Bucknam, and was never in serious trouble again.
Damn, that's a good summary, Bruce.
Yeah, I ought to be a sports writer.
Yeah, that was very interesting, Bruce. And the next item here is a headline that says Apollo number 4,900 to orbit the Earth. The Aerospace Defense Command has entered Apollo 14 as number 4,900 in its records of Earth orbiting satellites. The ADC housed inside Cheyenne Mountain is providing NASA with information on satellites passing near Apollo 14 during its journey to the moon. Just thought you might be interested in that.
Well, they say always better late than...
breathe. It's friendly.
It's better to be number 4,900 than not to be at all. And meanwhile, today at New York, the doors of baseball's Hall of Fame swung open for 7 old-timers elected by a Veterans Committee after the regular ballot of the Baseball Writers Association of America had failed to name any moderns to the shrine. Legendary pitcher Rube Marquardt, who shares a record of 19 consecutive victories in a single season, and George M. Weiss, the executive genius who built the New York Yankees into an awesome powerhouse from the late 1940s, led the advance of the old-timers. Also named were outfielders Harry Hooper, Joe Kelly, and Chuck Heffey, first baseman Jake Beckley, and shortstop Dave Bancroft. Marquardt, who won 201 games pitching mostly for the New York Giants and Brooklyn Dodgers from 1908 to 1925. Hooper, who hit 281 in 16 American League seasons, and Kelly and Beckley, both pre-1900 stars, were named as real old-timers whose careers ended by 1925.
And here's another startling bit of news from London. The headline says, subway riders arrive, can't get out of station. More than a dozen passengers were trapped in a London subway station for more than an hour early today when the staff locked up and went home. That sound familiar? When the passengers got off the last train on the Bakerloo line at the Maida Vale station in Paddington, they found exits blocked by steel shutters and the stations deserted. Police were called and they in turn contacted London subway officials. A spokesman for the London Transport said it would investigate the incident. London subway service shuts down from about midnight to 5 a.m.
Could happen to anyone, any place.
Also in the news is this other item from London, that D-Day is less than 2 weeks away. They're referring here to the day when England changes to decimalized currency. The government agency coordinating the switch says everything is going smoothly. Our latest survey has shown that since November, there has been an incredible improvement in the extent to which people are familiar with decimal equivalents, a decimal currency board spokesman said Sunday. On February 15, the new pound, worth $2.40, officially will become worth 100 new pence.
And next on the agenda here, vehicles are called the top noisemaker. Dateline is from Paris. Motor vehicles are the chief source of city noise and only governments can do anything about it. This opinion is the result of a 2-year study by the Consultative Group on Transportation Research of the Organization for Economic Cooperation and Development. Incredible. This problem is worldwide.
Seems like you do have a good hand on world events, important world events.
From Lorenzo Maquet, Mozambique, this item, fresh floodwaters have poured into Portuguese East Africa's cyclone-stricken lowlands today, hampering rescue efforts for thousands of flood victims already marooned 4 days. The central government said 135,000 persons lived in the worst affected area around Quelimane, administrative capital of the central Zambezia province. Only 24,000 people have been rescued, but Zambezia Governor Lieutenant Colonel David Ferreira declined to estimate the death toll. Good night, Fred.
Very good. Good night, Bruce.
Tremendous.
Very nicely done. Very nicely done.
We had to censor the best parts.
Say again?
We had to censor the best parts.
That's too bad. It'll be a daily show, I assume.
Oh, we'll see what we can do.
Houston,
14.
Hey, Bruce, I'm going to take some pictures of this S-4B area this time around. Do you want me to have the two strips at 24 frames per second for 2 seconds and everything, just like on the other sequence?
That's affirmative, Stu.
Okay.
All right, 14 Houston, if you feel like doing a little paperwork here, I've got an update to the in-flight erasable load procedure as a result of the new PIPA bias and gyro compensations uplinked to you just prior to Midcourse 2.
Okay, stand by 1, Bruce.
14 Houston, page 9-4 in the GNC checklist. Load A for Albuquerque. Under identification number 03, the old value is 77143. New value 76674. OID 05, old 00110, new 00320. OID 07, old value 76745, new value 77417. OID 11, old value 00477, new value 006, make that 00063. Read back, over.
Okay, under column A, 03, 76674, 0500320, 0777417, and 1100063.
Roger, read back correct. For cryogenic hydrogen management, we'd like to turn the heater in hydrogen tank number 2 off. And our calculations show that your paracynthian altitude is currently 67 miles. As the period of our tracking improves, we expect this to work down towards about 60 nautical miles. And we have a question for you. Have you noticed any cosmic ray flashes during your last sleep period or at other times when the command module was darkened, over?
One at a time. Houston, you say hydrogen 2, heater off, over.
Roger, H2 tank number 2, heater off. We'll call you when we want it back to auto or on.
Okay, it's off now. And Jay verily saw a few flashes. I'm not quite sure what they were ascribed to, but nevertheless we saw flashes during the sleep period last night.
Okay, was this...
Unfortunately, we were a little bit too tired to conduct any sort of measured experiment or data with them, but maybe we'll get around to that the next few days.
Roger, one question. Would you say that you were dark adapted when you saw these, or did you see them before you were well dark adapted?
I only speak for myself. I didn't start seeing them until after I woke up 3 or 4 hours after going to sleep.
Hey, Bruce, I had a comment I noticed on that last night. I'd wake up several times and I'd turn on the lights, take a look around PTC and that O2 flow that's been troubling us. And then I'd close my eyes again and I'd see some flashes real soon after I had been looking at these lights. Now, they were rather subdued lights, but, I certainly wasn't totally dark adapted.
Okay, what sort of lights were you using? The floodlights or the integrals?
Using the integrals, mostly, several occasions, I did have the floods up to check, and then I turn them back off again, and didn't seem to matter much.
Okay, thank you, 14. 14 Houston, for your information, the program alarm was a 404, trunnion angle greater than 90 degrees.
This is Apollo Control at 34 hours, 23 minutes ground elapsed time. Gold Team Flight Director Jerry Griffin is being briefed by each of the console positions here. Each man runs down the items that he has upcoming for this shift. The off-going Flight Director Milton Wendler, accompanied by his Flight Dynamics Officer Bill Boone, are en route to the Houston News Center, where they will have a change of shift briefing for newsmen in the small auditorium. Apollo 14, with very little conversation from the crew in the last several hours, is now showing distance from Earth of 127,737 nautical miles, velocity 4,051 feet per second. At 34 hours, 24 minutes ground elapsed time, this is Apollo Control.
Houston.
Go ahead, Fred.
I wonder if you can verify for us that you have H2 tank number 1 to auto and H2 tank 2 to off.
Let's verify.
Okay.
This is Apollo Control at 34 hours, 36 minutes ground elapsed time. We're anticipating no immediate conversation with the rather quiet crew of Apollo 14 and during the period that the change of shift press conference is underway at the News Center in Houston. The conversations, if any, will be recorded on tape for subsequent playback. At 34 hours, 36 minutes ground elapsed time, this is Apollo Control. This is Apollo Control at 35 hours, 5 minutes ground elapsed time. During the change of shift press conference, some 3.5 minutes of air-to-ground conversation was recorded on tape for playback at this time. Presently, Apollo 14 is 129,338 nautical miles out from Earth, traveling at a velocity of just about an even 4,000 feet per second. Some of the major milestones are, at least from statisticians' point of view, halfway point in time between liftoff and lunar orbit insertion will come at 40 hours, 56 minutes, at which time the spacecraft will be 142,119 miles from Earth and 81,723 miles from the Moon. The anticipated time for crossing the so-called equal gravisphere between Earth and Moon will be 66 hours and 3 minutes and 7 seconds. I believe that tape may be ready now for playback, so let's roll that 3.5 minutes and resume live monitoring of air-ground.
Okay, Fred, we just went through the Hicon and everything checked out real fine, and we ended up with magazine W on it.
Okay, copied, and you ended up with magazine W.
Right, that's per the plan.
And Fredo, do they want these times and days at this point?
That's the permit. I guess they like the times, and they like how many frames used off the other mag that was on there.
Okay. Mag V is in Victor. We started with frame 0 and ended with frame 9 before resetting the counter. The LTC clock is on day 764, and 0730 corresponds to GET of 342642.
Okay, copy.
Hey, Houston, they can play a lot of tic-tac-toe on the next 2 or 3 pages of this flight plan.
Say again, Ed.
The next 3 pages of the flight plan are very bare. We can play tic-tac-toe all afternoon on those.
All afternoon, huh? It's about 0200
You're right, it's
down
afternoon.
here.
We just had lunch a few minutes ago. It's afternoon.
Okay. Yeah, I have to agree with you about the next few pages. They do look pretty slim. 14, Houston.
Go ahead.
The photo people would like
Go ahead, Fredo.
Yeah, the photo people would like to know if y'all got the S-IVB pictures using the dim light Earthside settings there, and about when you did that, if you remember.
And we took some pictures. Whether we got them or not remains to be seen.
Is that a pun?
Roger. Say again. Pictures were completed at 34:03:25, and they're on magazine J for Juliet.
Okay, you shot them at 34:03:25 on Mag Juliet. 14, Houston. Hello, 14, Houston.
This is Apollo Control. That completes playback of the accumulated tape. We're now live with Apollo 14, continuing to monitor the air-ground loop.
Apollo 14, Houston.
Go ahead, Houston.
Okay, I have an LOI minus 5-hour flyby maneuver pad for you that we owe you about this time.
Roger, and LOI -5, flyby.
You got the good book out, ready to copy?
That's affirmative, let her rip.
Okay, SPS/GNN 63526 plus 090 minus 033 076 59er 3154 plus 03823 minus 01043 minus 00084 246 208 062 N/A plus 00212 039er 64 056. 039er 12. 22. 2117. 087.
Hold it, Phantom.
Okay.
Start back with Delta VT, please.
Okay, Delta VT 039er 64. And 056. 039er 12. 22. 2117. 087. The next three lines are in/A. Then noun 81, noun 61s are minus 2786, minus 16802, 1149er 8, 3615er. And the last item, GET 05G at 1651225. Under comments, GDC align set star, Sirius, and Rigel. R align 230. P align 170. Yaw line 002. No knowledge. And the burn is SPS docked based on the PTC ResMet.
Okay, I think I missed two items that are the down 40 weight and HCP, if you get it.
Okay. The noun 44s at apogee was in/A, perigee plus 00212.
Roger, and noun 47, the weight.
Okay, weight 63526.
Okay, I have an LOI minus 5, SPS GMN 63526 plus 090 minus 033 at 06759 3154 plus 03823 minus 01043 minus 00084 246 208 262. HA is NA plus 00212 03964 056 03912 22 2117 087 foresight star NA. Noun 61s minus 2786 minus 16802 11498 36159 1651225. Sirius and Rigel at 230 170 002. Knowledge. It's an SPS docked burn with PTC ResMet.
Okay, Ed, everything's okay except two items. Apparently one of us got our flip-flops wrong here. For the attitude block, yaw should be 062. And the noun 33 hours should be 076.
Roger, the hours are 076 on 33, and yaw is 062.
Okay, good read back. to see if y'all still around there. Y'all been looking out the window lately back in this direction? See anything interesting?
No, I've looked out for a while. Got something interesting for us to look at?
Well, I was asking you if you had seen anything from that vantage point. Pretty dark down here where I am right now.
It's been an hour or so, Fred, since I took a look at either back in your direction or at the moon. Let's see if I can see where you are now.
I guesstimation on Terminator ought to be somewhere around India, Pakistan, somewhere in that, along that line.
Okay. Houston 14. We have the moon out the hatch window right now, Fredo.
Okay.
And I would presume then that the Earth is probably out toward telescope at this moment.
Yeah, I guess you'll have to wait about another 20 minutes or so for it to come up in the hatch.
Right. Yeah, I suspect also it's now just a little bit too far for us to see.
Let's see, how big a moon are you seeing there? Is it about not quite a half or something?
Right, it's short of a half. And for size, it appears about like an orange held at just short of arm's length. Probably subtends about 1.5 degrees now, or a little less.
All right. Yeah, the board here has you at about 135,000 out now.
Okay, that'll make it just slightly over a degree then, I guess. You already know, Fred, the moon starts to take on a little bit of brown or grayish colors about this point, as opposed to being so very bright as it appears from the Earth. We can start to see a little bit of texture here.
Yeah, that's a good word to remember, that texture business.
Yeah. And Fred, I have a binocular on the moon now out window 5, and it's really starting to look very interesting from this point of view. Houston 14.
Go ahead, 14.
I have the home planet out the hatch window now, and where did you say the Terminator is?
Oh, guesstimation was somewhere between Sudan and India.
Roger.
And looking at your position overhead here, you ought to have Philippines, mainland, the Far East in sight.
As a matter of fact, I do, Fred. There's quite a bit of cloud cover, and I'm having a little difficulty identifying land masses. I'll be able to pick it up for the next time around here.
Okay. And 14, Houston.
Go ahead.
Yeah, I was trying to give you a sunrise Terminator there, Ed. I guess from your, I got some pictures here that tells me that what you're probably looking at is a sunset Terminator. And that's running right through Australia, and right across the coast of China.
Okay, right. That makes a lot more sense, Fred. I'm pretty sure I had the Australian continent down the bottom of my light area and looking up across the Philippines. And there's a great deal of cloud cover in that area, but there are a few islands standing out. I believe that I can see the southern tip of India standing out without too much cloud on it.
Roger, India should be right about at the edge.
Right. Houston 14.
Go ahead, 14.
Is there still a fairly sizable tropical storm off the east coast of Australia?
Okay, I'll ask somebody about that one, Ed.
Part of it seems to be in darkness right now, but I seem to be seeing about half of a very large circulating air mass.
Roger, Ed. Okay, stand by one, Ed. We got kind of a bad comm right now. Okay, I think we're maybe back on the good Omni now. Ed, go ahead.
Okay. I didn't have...
Say that last again, Ed.
I say I don't have very much viewing time of either the moon or the Earth as it swings past the window. It's very low, and we only have just a few minutes on each window. But it's the most inviting and magnificent view. I'm very glad we have Earth as a home planet. I hope we can keep it so it's inviting.
Roger, Ed. Yeah, again, looking up at the big board, I can need to get about another 40,000 miles or so, then you'll be more directly in the Earth-Moon plane, and you ought to have them pretty much centered in the window about then.
Okay, no, thank you. Houston, Apollo 14.
Go ahead, Ed.
Right, Fredo, I'm watching at the right-hand rendezvous window at the thermal scan on the lamp. Right now, it's in full sun outside my window, and I observed as the sun came directly onto it, expands in the heat, and then cools off and pops back into shape again as it starts to cool off on the next cycle. It gives a rippling effect as the sun passes across it. It's very interesting.
Uh, 14, Houston.
Go ahead.
Okay, I heard a little bit of your onset there, Ed, before Omni B got us again with the bad comm there. And I guess LEM 8 got built just like LEM 7, because I noted that same sort of thing there.
Yeah, I guess that's what it's all about. Good thermal protection that expands with the heat and contracts, and this is sure doing it on each cycle.
With respect to your weather question a while ago, Ed, they say they do have a weak cyclonic storm to the west of Australia, but they're not showing anything to the east, and maybe I misunderstood, but I thought you said you saw it over by the Sunset Terminator to the east.
Right, it appeared to be by the Sunset Terminator. I've got a very, like a donut-shaped cloud that's several thousand miles across. It might have been too large for just the tropical storm they're talking about. It seemed to be a very widespread circulation.
Yeah, I guess I need to go look out the window down there too.
Okay.
This is Apollo Control, 37 hours, 7 minutes ground elapsed time. Very sparse conversation coming from the crew of Apollo 14. This crew won't be noted for being verbose. Some gee-whiz numbers on the mission. Present distance from Earth, 133,930 nautical miles. Velocity, 3,851 feet per second. At 37 hours, 7 minutes, ground elapsed time, continuing to monitor air ground as long as the crew is awake. This is Apollo Control.
Apollo 14, Houston.
Go ahead, Houston.
Okay, we're ready to suspend battery charge on A.
Okay, doke.
It's all filled up again.
And hear it. Houston 14.
Go ahead, 14.
At 39 hours, the map command module Delta P is reading 0.75.
Roger, 0.75.
Correct.
Houston.
Go ahead, Houston.
Is Ed around with a headset on?
Affirmative.
Okay, Ed, I'm not,
Mr. Federal.
yeah, I'm not maybe clear on a question you had earlier about the ball valves with respect to time in the burn on MCC2, but I do have some data here. And I think the crux of it is that if you use a cue of the ball valves visually showing full open to full closed, you'll be shifting your what you're actually starting and stopping your clock by about a quarter of a second from the actual chamber pressure. But the total delta of time is very close. On that burn, you would have clocked 10.15 versus 10.2 via PC.
Okay. You say had we measured PC, we would have clocked 10.15. Is that firm?
No, you'd have, from 90% PC down to 10%, you'd have got 10.2 seconds. And if you'd have started your watch with bank A full open to the bank A needle showing full closed, you'd have measured 10.15. Except you'd, in the absolute time scale, you would have started and stopped your watch 1/4 second to the right. Because there is a lag in the, what I'm telling you is there's a lag in those needles moving by about a quarter of a second from what the actual chamber pressure is.
Okay, I understand.
Houston.
Go ahead, Houston.
I know you'll be happy to hear that we won't have a need to do the uplink here at 3940. The state vector looks in great shape as is.
Very good. Glad to hear that. You're right.
We won't have to work that in this busy schedule here.
Okay, we'll proceed to the next item.
This is Apollo Control, 39 hours, 59 minutes ground elapsed time. Flight surgeon just reported a few moments ago that apparently lunar module pilot Ed Mitchell had unplugged his biomed harness and apparently was preparing to go to sleep. They're somewhat ahead of schedule on this particular item, and that the rest period is not scheduled to begin until 41 hours ground elapsed time, which is almost 2 hours from now. 1 hour from now, I beg your pardon. I don't see how it could be much quieter, whether they were asleep or awake, judging from the past several hours' sparse conversation. Apollo 14 now 140,147 nautical miles out from Earth. Velocity 3,657 feet per second. An update for S-IVB impact, which was run at 37 hours approximately ground elapsed time, shows the impact point at 8 minutes 52, as you were 8 degrees 52 minutes south, 25 degrees 51 minutes west, at a ground elapsed time of 82 hours 37 minutes 33 seconds. At 40 hours 1 minute ground elapsed time, this is Apollo Control.
Okay, and we see you're now 93s. Roger, 0401100. Houston.
Go ahead, Houston.
Okay, the PTC is divergent enough it's not going to make it through the next this upcoming sleep period, so we'd like you to stop at about 0 roll, and we'll reinitialize. In the interim, you can do any venting or dumping you might have to do before cranking it up again.
Doctor at the moment with food and everything. We'll probably catch you in the next cycle round.
Okay. Okay, and either 0 or 180 roll will be okay.
Okay.
And 14, Houston, who's the duty cook tonight? Go. Hello, 14, Houston. Okay, we'd like H2 tank number 2 to auto.
Okay, H2 number 2 going to auto now.
Okay, that's a heater switch, Al.
Yes, middle.
This is Apollo Control at 41 hours 25 minutes ground elapsed time. According to Flight Surgeon Willard Hawkins, here in Mission Control, the only one still apparently awake is Commander Shepard aboard Apollo 14, and he apparently is settling down into the easy rhythmic breathing of one going to sleep. But Rusa and Mitchell apparently have been asleep for some time. Apollo 14 now 143,114 nautical miles from Earth, traveling at a velocity of 3,568 feet per second. At this time, we will take down the air-to-ground circuit, and should the crew wake up and make a call back to the control center, we will tape this for delayed playback. At 41 hours, 26 minutes ground elapsed time, this is Apollo Control. This is Apollo Control at 41 hours, 33 minutes ground elapsed time. Apparently not everyone is asleep up there, because we had a call just a moment ago offering the crew status and onboard readouts. So we'll play catch up with tape and go live as quickly as we get through the brief burst of tape. Let's go.
Houston 14, we're ready with our crew status report and with a verb 74.
14, Houston, got a new Capcom now. Stand by 1 before you start that report.
Okay.
New Capcom referred to is Gordon Fullerton, who is replacing Fred Hayes at the Capcom's console. Some handover going on here in the room. Pete Frank being briefed by the outgoing flight director, Jerry Griffin, who will be coming to the news center as soon as the handover is complete for a briefing on God only knows what. But at any rate, he'll be coming over that way. We're standing by live on air ground at 41:35.
Houston 14.
14, Houston, go ahead.
Okay, Gordon, Fred made his comment before you left. I guess you're wanting us to reestablish PTC before we take out. Is that affirm?
Affirmative.
Okay.
Apollo 14, Houston.
Go ahead, Houston.
Roger, we're waiting for a good Omni to come up before starting that e-memory dump. One reminder is to complete all dumping before you try to start the PTC again. And a question. With respect to the O2 flow high problems you had yesterday and any that you might have had since, we're wondering if you're doing anything different than normal procedures as far as the waste management overboard drain or any other outside drains to control O2 flow high problem. Over.
That's a negative on the procedures. We're not doing anything unusual there, and we haven't had any problems today. The O2 flow you saw a minute ago as we were pumping up the cabin to 5.7, and as far as the ones that we had yesterday, really don't have that psyched out.
Roger, Stu. 14 Houston, we're ready for the EMOD dump.
Okay, Gordon, Verb 74 and coming at you.
Roger. Apollo 14 Houston, we're ready to copy your crew status report and onboard readouts. Over.
Okay, respect to the crew status. It's excellent. We have a negative medical report. At C is 37.0. Pyro A 37.2. Pyro B 37.2. RCSA 87. RCSB 89er. C86. C88. That was taken at 0412000.
Roger, Al, would you say bat C voltage again?
37.0.
Roger. We copy all those.
Go ahead.
This is Apollo Control, Houston, at 41 hours, 53 minutes, now to the flight of Apollo 14. Our displays show Apollo 14 presently 144,049 nautical miles away from the Earth and traveling at a velocity of 3,540 feet per second. The change of shift has been effected in the Mission Control Center. The orange team of flight controllers replacing the gold team. There will be a change of shift briefing in the small auditorium of Building 1 in approximately 10 minutes. This would be a change of shift briefing with Flight Director Jerry Griffin. The modular space station news conference has been moved from the 9:30 time to 1:30 p.m. this afternoon. I repeat, the modular space station news briefing has been moved back to 1:30 p.m. This afternoon. At 41 hours, 54 minutes into the flight of Apollo 14, this is Apollo Control, Houston.
Apollo 14 Houston, over.
Go ahead, Houston.
Roger, we're within rate limits and looks like a good place to start the roll rate for PTC.
Okay, we're going to hang loose here for a few minutes before we spin it up.
Roger, Stu. Apollo 14, Houston.
Go ahead, Houston.
Stu, when you do get ready to spin up, let us know before you do, and we'll catch it at a good point to start it and give you a go. Over.
Okay, that sounds like a good plan. We want to make sure that got all the activity quieted down before we spin up.
Roger.
This is Apollo Control Houston at 42 hours, 5 minutes now into the flight of Apollo 14. Our displays now show Apollo 14 at a distance of 144,443 nautical miles away from Earth. Velocity now reading 3,528.5 feet per second. At this time, we will take the line down and switch to the change of shift news conference. At 42 hours, 5 minutes, this is Apollo Control Houston. This is Apollo Control Houston at 42 hours, 32 minutes into the flight of Apollo 14. Apollo 14 now at a distance of 145,367.8 nautical miles and traveling at a speed of 3,501 feet per second. Since our last report, Capcom Gordon Fullerton has had only a brief contact with 14 with command module pilot Stu Rusa. We'll play that for you now.
Houston 14.
Apollo 14, Houston, go ahead.
Okay, Gordon, I think we're through with all our venting for the present time. Anytime you say, we'll spin up.
Okay, stand by. I guess I want to wait here a little bit.
Okay.
Apollo Control Houston, surgeon data indicates that spacecraft commander Al Shepard, Stu Rusa, and Ed Mitchell are still awake, but apparently getting ready to start their rest period. We're at 42 hours, 34 minutes into the flight, and this is Apollo Control Houston.
Apollo 14, Houston, looks good now for starting spin up.
Okay, Gordon, we'll give it a go.
Apollo Control Houston, 42 hours, 43 minutes into the flight. That brief exchange of conversation between Capcom Gordon Fullerton here in Mission Control and Stu Rusa, the command module pilot. We now show Apollo 14 at a distance of 145,757 nautical miles, traveling at an ever-decreasing speed or velocity, now reading 3,489 feet per second. We'll stand by and continue to monitor here in Mission Control, and this is Apollo Control Houston.
Apollo 14, Houston.
Go ahead.
Roger, I'm sorry to have woken you up if you dozed off. We'd like you to check the S-band normal mode voice switch off prior to going to sleep here.
Okay, stand by.
Apollo Control, Houston, 42 hours, 57 minutes. That was Al Shepard responding to Capcom Gordon Fullerton's call. 14 now, 146,192 nautical miles away from Earth. Present speed reading 3,476 feet per second.